function. It's always where you want to start with transformations.
Okay.
Figure out what the parent function is, and I'm going to call it g of x. In other words, it's not f of x.
Okay.
What's the parent function?
Shoot.
You've only been taught like 10 elementary functions.
Okay.
You've been taught y equal mx plus b, that's one. You've been taught y equal x squared. You've been taught y equals square root of x. What would this parent function be?
Would this be x squared?
Absolute value of x.
Oh, okay. How would you know, like...
Because I'm looking at absolute value signs.
That will tell you if it's the absolute value of x.
Yeah, in other words, if you see absolute value signs, then that's almost always this is going to be the parent function.
Gotcha.
Pretty much 100% of the time.
Cool.
Certainly at your level of algebra.
Yeah.
Okay. Now the key is figuring out what has been done to it. In other words, how has this absolute value of x been changed by f of x?
It's been shifted -2, -3. Or, no.
That's actually pretty good answer, but not specific enough. One is a horizontal shift, one is a vertical shift.
Within the absolute value, it would be a horizontal.
Good. Of -2, that means left 2. That's what your answer should have been. Is it shifted left 2, and then the -3 means what?
Shifted down 3.
Yes. In other words, vertical shifts are always up or down. Horizontal shifts are left or right. Now,
Okay.
what does the minus sign in front of the absolute value mean?
It's reflected over the x-axis.
Good. That's it.
Cool.
Those are your 3 transformations.
Sweet.
Okay. Now they do get a little harder. The second one, what's the parent function?
G of x is equal to x.
Absolute value of x, right.
Absolute value, yeah, my bad.
Yeah. Okay. And what 3 things are being done to that? Start on the left. Actually, let's go back a second. You should always start with reflections. If you were going to graph this, you would not want to do your horizontal and vertical shifts first and then reflect it. You'll get a different looking graph.
Okay.
Any reflections, whether they're over the x-axis or the y-axis, have to be done first.
Okay.
Okay? Everything else, order does not matter. You can do stretches, shifts, squeezes, all of that in any order you want. But if there are reflections that need doing, you have to do them first.
Okay.
So what's the consequence of the 2?
That's the line where it's reflected over.
No, that's a vertical stretch factor.
Oh, okay.
Okay, and here's what the consequences would be. Here's what g of x looks like. Okay, so what does 2 g of x looks like? Because that's what that 2 is doing. Is it's multiplying g of x, right? In other words, 2g of x is going to be this. Well, that's pretty close to what we got, or at least as part of it.
Okay.
And because it's outside the absolute value sign, it's a vertical action, and it is a stretch. And what it's telling me is that every point on my stretched curve is going to be twice as far away from the x-axis. Notice that if I had a point right there on the original curve, it's now up there, twice as far away.
Okay.
If I have a point here and the new one is there, that's exactly twice as far away. That's what a vertical stretch by a factor of 2 does.
Okay, that makes sense.
If it was a 3, then it would have to be 3 times further away.
Okay.
The net effect is that when you have the absolute value function, it makes it skinnier.
Okay.
A vertical stretch factor makes it narrower. If it was a 1/2, then it would be down here. right?
Right.
Because every point would have to be twice as close.
Okay.
Okay,
So for
so
so
vertical
if it
squeezes flatten the curve. Vertical
yeah.
stretches narrow the curve.
Okay. So if it was a vertical shrink, that'd be a fraction.
That's
So if it's 2/3, it'd be a vertical shrink.
right, and it would look more
Cool.
like this. In other words, it would have
Okay.
the effect of flattening out the absolute value curve, which
Okay.
originally looks like this.
Cool.
Okay, so let me erase this bottom one so I don't confuse with too many curves. So the
You're fine.
red is the first thing I did, and I vertically stretched it. So this
Cool.
red curve is that one right there. Now let's do
Cool.
the other two things. I'll do them in two different colors. So
Okay.
the order that I do these other two things does not matter.
All
So
right.
what's the consequence of the -1 inside?
Um, it'd be horizontally shift right.
Good. By how many?
By what am I on? Yeah, by 1.
By 1. Exactly. Well, if I take
Cool.
my red curve and I shift it horizontally right, looks like this.
Sweet.
Okay, so this curve is y equals 2 absolute value of x minus 1. Now I only
Okay.
have to apply one other thing, and that's the +1 at the end. What does that do?
Um, it's a vertical shift up 1.
So I take my one point that I know, the vertex, and I move it up 1.
Uh-huh.
And then
Yeah.
I draw the same shaped curve. Because
Cool.
I don't want to apply that vertical stretch factor again. So
Yeah.
the final graph is the blue.
Cool.
And you don't have to do these one step at a time, but it kind of helps actually.
It
It
does,
helps,
yeah.
helps understand how it all works. Okay.
Uh-huh. For
And
sure.
let me suggest we skip C because I want to get
Yeah,
on to D. C
cool.
is the same degree of difficulty as B was. You'll
Yep.
notice that it's almost the same problem, just with different numbers, right?
Uh-huh. Exactly.
Okay.
Yeah.
Tell me what's happening on C. We won't bother graphing it. Just tell me what's happening.
Yeah, I said it was a vertical shrink by 2/3 and then a horizontal shift
Which way?
left 4 uh up by
Horizontal is
2/3.
left or right?
Or I mean right 2/3.
Hold on. It's a
Or would
vertical
it be left?
shrink by 2/3. You got that right.
Uh-huh.
But then this 4 is what?
Left 4.
Good. And then the plus
And then
3 is what?
up 3.
Okay. That's all they're really asking.
Yeah.
We won't go through graphing of it since we've done that.
Sounds good.
This is a little different.
Uh-huh.
This is a little harder, this
Okay.
one. And the reason is how to handle that negative sign. First of all, if I said that alone, what is that?
Minus,
No,
so
it means a reflection over which axis?
over the y-axis.
Correct, because what it really is f of minus x. In other
Yeah.
words, or g of minus x. If g of x is absolute value of x, then what we're looking at is g of minus x, right?
Okay. Uh-huh.
And that means it's inside the function, and so that would be a reflection, a horizontal reflection, which is a reflection over y.
Yeah.
Now, here's the kicker. And this is what makes this one so hard.
Okay.
Is reflections have to be done first. So
Okay.
if my f of x is equal to this, let's ignore the +2 for just a second.
Okay.
I have to change that so that it looks like this. See how that's the same thing?
Uh-huh. I do see that, yeah.
And the reflection, since it has to be done first, it has to be in front of everything in the parentheses.
Okay.
Okay? And
Yeah.
notice I had to change the sign on the 5 to a plus to make it work. In other words, this has to be the same as this. Well, it is
Yeah.
now. Once I add the parentheses, I have to change the sign on the constant.
Okay.
Now, what is this?
So this would be
First, start with the
a
reflection.
horizontal, yeah, horizontal
Start with the
shift.
reflection.
Um,
Always start with the reflections first. Always. If you
okay, so
do
this
them
would
out
be,
of order, you may not get the right answer.
so this would be reflection over the y-axis.
Correct? By that negative sign.
Uh-huh.
And now what else?
Hold on.
Horizontal shift which way?
And then it'd be horizontal shift right
No.
1.
Remember, it's always x minus h. So in
X.
this case, it's a horizontal shift left by 5.
Okay. Oh, okay.
You see why?
Yeah, because it's a +5 in the parentheses.
Yes. If that's a
Cool.
plus, then it's a shift to the left by that amount. If that's a
Okay.
minus, then it's a shift to the right by that amount.
Okay. That makes
But
sense.
regardless, notice the mistake that virtually everybody is going to make on this problem. They're going to see
Uh-huh.
that negative sign. They're going to say, okay, that's a reflection over the y-axis. And then that looks like a shift to the right of 5 units.
Yeah.
But it is not once you add the parentheses. And you have to add the parentheses.
Okay.
This minus sign just being in front of the x is not enough, because what I'm really looking at is g of minus x plus 5. That's what I'm looking at right there.
Okay.
Okay, and that translates to minus x minus 5.
Yeah.
Okay, and then the last thing here was the plus 2. What does that do?
Oh, for
Number
the,
t, yeah,
yeah, so I see it as a horizontal shift, left 5 and then up 2.
correct.
Cool.
All right. E is a little different.
Yeah, it looks a little different.
Notice that everything going on with E, not everything, but most of it is inside the parentheses. So
Yeah.
what are those things going to be? What is that 2 going to do, and what's the minus 3 going to do? Are they going to be horizontal effects or vertical effects?
Let me see. It'd be horizontal.
Right. If it's inside the function, it's always horizontal. There's 3
Cool.
horizontal things you can do, and there's 3 vertical things you can do. All of the
Okay.
vertical things are outside the function.
Yeah,
If
and
I
it'd
put a
be,
negative sign there, that's outside the function. That's a vertical reflection.
okay, so it'd be reflection.
Sign inside, that's a horizontal reflection.
Yeah,
Okay.
for sure.
So what 3 things are going on?
So it'd be a reflection over the x-axis.
No, I don't see any negative sign.
I mean y-axis.
No,
Well,
there's no
wait.
negative sign inside either. This negative 3 is a horizontal shift.
Oh, that's it. So it's no reflection.
No, there's no
Okay.
reflections going on. You need the negative sign to be in front of the x for there to be a
Gotcha.
reflection.
Okay, so it'd be a horizontal shift, right 3.
What's the 2 do?
Um, that,
That's a horizontal shrink factor.
shrink, okay.
It's the
Horizontal, so it'd be,
opposite of vertical. When you're looking at vertical stretches or shrinks, what matters is whether the number is greater than 1 or less than 1, right?
right.
In other words, if I have 3x, that's a vertical stretch. If I have
Yeah.
1/3 x, that's a vertical shrink.
Okay.
With horizontal, it's the exact opposite. If I
Okay.
have 3x with horizontal, that's a horizontal shrink. And if I have 1/3 x, that's a horizontal stretch. So
Gotcha.
just remember that they're opposite one another. If you can remember the verticals, then just know the horizontals is the opposite. Numbers greater than 1 are shrinks. Numbers between 0 and 1 are stretches. Notice that it's not just less than 1. It's got to be between 0. In other words, -2 is less than 1. But if I put a -2 there, that's a shrink. First of all, a reflection over the x-axis, and then it's a shrink if it's horizontally.
Gotcha.
Just remember your horizontal and vertical stuff are different. And what was the -3 again?
So it'd be a horizontal shrink, and then it would be
Always
horizontal.
way.
Yeah,
shift.
right 3. Yeah. Right 3.
And then what's the +6 do?
Up 6.
Okay.
Cool.
All right, we're getting good at these. Let's start from the left. What's the minus sign do?
All right, hold on. Okay. So it would be, the minus would indicate that it's a reflection over the y-axis?
No.
Or x-axis.
Here's the way I want you to think of it. You have vertical adjustments and horizontal adjustments. All of the vertical adjustments are outside the function. And this minus sign is outside the function, the 2 is outside the function, and the 5 is outside the function. The only thing inside the function is that -3. Well, that must be a horizontal shift then. So that's the way to learn it, is there's 3 verticals and 3 horizontals, and all of the verticals are outside the function, all of the horizontals are inside the function. So the negative has to be a vertical reflection. A vertical reflection is what I would call a reflection over the x-axis, right? I mean, you see why I call that vertical? If I have a function like this and I reflect that over the x-axis, I'm doing a vertical reflection.
Gotcha. So it'd be a horizontal shift and then a...
First of all, what's the 2 do?
It's a horizontal shift.
No, hold on. Stop. All things outside the function are vertical. All things.
Gotcha.
So the negative sign has to be something vertical. The 2 has to be something vertical. What is it?
Minus down 2.
No. It's a stretch factor. In other words, when it's multiplying the function, you're looking at either a vertical stretch or a vertical shrink. Stretch and shrinks factors change the shape of the curve. Shifts do not. In other words, if I take my absolute value curve here and I shift that right or left, it's exactly the same shape.
Right.
If I stretch it, it's not the same shape anymore. If I shrink it, it's not the same shape anymore. No. So stretches and shrinks are significantly different than vertical shifts or horizontal shifts. Vertical and horizontal shifts do not change the shape. Stretches do, and that's outside the function, so it's vertical, and it's a stretch because it's over 1. Forget the fact that it's -2. We already took care of the negative sign. The negative sign meant that it was a reflection over the x-axis. The 2 means it's a vertical stretch. The 3 means it's a horizontal shift to the right by 3 units, and what's the 5?
Up 5.
A vertical shift of up 5, yes.
Yeah.
Just saying up 5 isn't maybe quite enough. You need to say vertical shift. Remember that there's a lot of S words here.
Yeah.
They're hard to keep track of. There's shifts, don't change the shape. There's stretches, does change the shape. And there's shrinks, does change the shape. Okay? And they're confusing because they all start with S, and these two both start with SH. So it's tough to differentiate them. And horizontally, you have the same 3 things. You have horizontal shifts, you have horizontal stretches, you have horizontal shrinks.
Okay.
All right.
Wow. Okay.
We got enough time to probably cover this one right here.
Okay.
And the next one even.
Yeah. No, yeah.
The parent function is the skinny line. In
Yeah.
other words,
Yep.
I'm not sure what that says. Does that say f of 2x?
Yep.
You're kidding. Really? Equals. No, they didn't. Did they mean that?
I don't think so.
Yeah,
Because
they did.
that's on a calculator. He did this on a calculator. And,
Oh, I wouldn't
oh,
think he would say f of 2x. I just
yeah.
wouldn't think he would.
No, he
Okay?
wouldn't.
So he's saying that the parent function is f of x equals absolute value of x. And that's what that function looks like, is the skinny black line.
Yeah.
Okay? So first of all, what do you notice about the thick black line? Very first. Always think reflections, because those have to be done first.
Okay.
So,
It's a. Is it a reflection? No.
well, it's not just a reflection,
No.
but it's a reflection combined with a horizontal shift combined with a vertical shift.
Yeah.
But if I was doing just a reflection, I would take that line and
Uh-huh.
turn into that line. Okay?
Right.
Now,
That'd
the
be a
line we're looking at has more things happening to it. What? Is it the
um.
same shape? In other words, is it skinnier or flatter than this one?
It looks like the same.
Yes, it's exactly the same shape. And what
Yeah.
that means is there's no horizontal or vertical stretches or shrinks.
Uh-uh.
There are vertical and horizontal shifts going on. Like
Uh-huh.
what?
It's a horizontal shift.
How much?
Uh,
Which way direction?
right. Right three. So it'd be
Okay.
f of. So it'd be f of x is equal to absolute value. Uh, X minus 3.
Good.
And then it would be um, plus 0. So just that's
Hold
it,
on. If you
right?
take this point
Oh,
right here,
up 1.
right, exactly. It's been
Yeah.
moved up one after the
Yeah.
reflection.
Yeah.
And notice that I do not get that curve if I don't do it in this precise order. And
Uh-huh.
incidentally, I need the negative sign in front of the function.
Yeah.
So here's your answer.
Cool.
And in order of the way we did it. First of all, we saw, was there a reflection? Yes, there's a reflection
Yep.
over the x-axis. So I need a
Uh-huh.
negative sign in front of the function. And then there's
Yep.
also a horizontal shift and a vertical shift. So
Cool.
this is what you need. I'm not sure it's quite fair to call it f of x.
Okay.
F of x is the original function. This,
Uh-huh.
we call it g of x.
Okay.
G of x is the big fat, flat looking line. Now,
Right.
let's talk about interval or domain and range.
Yeah.
Describe the domain and range of the black thick line. What's the
Yeah.
domain? Just looking at it.
Wait, let me see here. 3. Positive 3.
What's the domain? The domain is all of the possible horizontal values that it can attain.
Um,
Can x be 0?
yeah.
Can x be 1?
Yep.
Can x be 100?
Uh,
Can x
yep.
be minus 1,000?
No. Yes, it can.
Good.
Yep.
So what's
Yep.
the domain?
Infinity.
In interval notation, it's minus infinity, comma, infinity. All real numbers. That's the same thing as all real numbers.
Okay, cool.
Okay, but they ask for it in interval notation. So I got to give it like this. You don't want to just say x equal all reals. Not, you'd lose points.
Yeah, for sure.
Okay? Now let's look at the range.
Okay.
And just look at the graph and tell me what is its lowest point going to be. Always start from the bottom and then go to the highest point.
Okay, so it'd be negative infinity to positive 1.
Good.
Cool.
And can it be equal to 1?
It can, yeah.
So should this be a parentheses or a bracket?
Bracket.
Just like that.
Cool.
And whether it's bracket or parentheses always depends on whether it can be equal to that. Sometimes you've got a vertical asymptote and it can't be equal to that. But in this case, it can be equal to 1. I'm looking at it right there.
Okay.
All right. Let's real quickly, in 1 minute, look at the second one there. So what also do we immediately see?
We see that it would be a vertical shrink.
Well, okay, but start with reflections. Remember, reflections always take priority.
Yes, it'd be a reflection over the x-axis.
Okay, so right off the get-go, I've got this. Okay, now, what else? You're right, it looks like a vertical stretch, not a shrink.
Yeah. No.
Remember, stretches make it skinnier. This looks to be skinnier. Okay. Yeah. So now I can say, okay, that looks like about a factor of 2. So getting closer, right? Now there's 2 other things that have happened to this point. That point is not where it started with. What's happened to it?
It's been horizontally shifted left 3.
Okay, how does that reflect in the function?
So it'd be minus 2 absolute value x plus 3.
Good. And then one last thing has happened to this function.
Minus 2.
Not just minus 2, Dylan.
Wait, let me...
Vertical? Is it horizontal? Is it a shift? Is it a stretch? You have to spell every single thing out. They've asked you to describe the transformation. So if you just said minus 2, you would definitely lose points.
Vertical shifts down 2.
Okay, which makes the function
minus 2.
And now you have the complete function. Now, what's the domain?
The domain would be all real numbers, so negative infinity to positive infinity.
Okay. And what's the range?
And then the range would be negative infinity to minus 2.
Good.
Cool.
All right. Dylan, you have a good rest of your day. And I'll talk to you tomorrow night. I think we have a session at 8, I believe.
I think so, yeah.
Let me just look real quick. Yeah, 8 o'clock. Oops, hold on. That's December 26th. We probably don't have that session. No, we have one tomorrow night at 8 also.
Yeah.
Okay. All right.
All right.
Have a good one.
Sounds good.
Bye-bye.
You too, Mr. Cowan. Bye-bye.